We are going to have to refresh our memory with trigonometry and think a little bit about triangles, at least for the first half of this first semester, because we're going to be dealing with motion in 2 dimensions, vectors and momentum and forces, which all will require us to use some angles and utilize triangles, right angle triangles in trigonometry in doing that. So we're just going to refresh some simple Pythagorean theorem and sine, cosine, and tangent. And that's what we're going to do right here. So for the first problem here, I have a right angle triangle. One side is 3 units. Another side is 2 units, and we're looking for the hypotenuse here, x. So in order to find the third side of a triangle, when you know the other 2 sides, you use the Pythagorean theorem. And if you remember your Pythagorean theorem, the Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse of your triangle A and B, or your other 2 sides. So c here is the hypotenuse. That's x. That's what we're trying to solve for. Now, we see that, so c, that's the same thing as x, but we see that it's squared here, okay? To get rid of that square, we have to take the square root of both sides. So then c, the length of my hypotenuse, is equal to the square root of a squared plus b squared. So my side that I'm going to call A is 3 units. I'm going to square it, plus my side that is B, the other side here, has a size of 2 units, and I'm going to square it. So then my third side, x, has a size of the square root of 3 squared plus 2 squared, which is equal to 3.6. Okay, it doesn't matter which side you use for A or B, as long as C, your hypotenuse, is this side right here. Now let's think about solving for angles in our triangle. Here I have my right angle triangle, and I know 3 of the sides. Triangles only had 3 sides. Our hypotenuse is always longer than any of the other 2 sides, so the hypotenuse has 5 units, our other side is 4 and 3 units. And I want to solve for both of these angles in this triangle. I want to solve for my angle theta and my angle phi. This is the Greek lowercase letter phi. So let's start with angle phi, or theta here. How will I find my angle theta? Well, let's remember that sine of any angle is equal to the opposite side over the hypotenuse. So if this is my angle theta, the opposite side would be this side right here, which has a unit of 4. And the hypotenuse would be this side here, which is opposite of the right angle of our triangle. Okay. Cosine of an angle is equal to the adjacent side divided by the hypotenuse. So for this angle theta, the adjacent side is this one here that has 3 units. My hypotenuse would be the unit, the side that has 5 units. And then tangent of theta, that's equals to the opposite side over the adjacent side. So for this triangle here, then I have that tangent of theta is going to be opposite, so that would be my side that has a unit 4 of length over the adjacent side, which is the side that has a unit length of 3. Okay, so let's go ahead and do this. Let's use for theta, we'll go ahead and use sine. You could use cosine or tangent too to find angle theta, but let's just use the sine that we have here. So we've got sine of theta is equal to opposite, so 4 over the hypotenuse, so 5. Okay, but we have to get theta by itself. Here we have sine theta. So to essentially get rid of this sine theta, we have to take the inverse sine. So when we do that, we see that theta is equal to the inverse sine, the inverse sine, or the arc sine, of 4 over 5, okay? And so the thing that I will point out to you here is be sure you know which mode your calculator is in and how to check or change the mode of your calculator. I'm going to use my calculator in degree mode. Usually it makes the most sense, not always, but the most sense for us, especially in the first part of our semester, to use our calculator in degree mode rather than radian mode. So if I have my calculator in degree mode and I say the inverse sine of 4 over 5, that should give me an angle theta of 53.1 degrees. Okay, so that's what I'll have for this angle theta here. Now let's find the angle phi. Now since I used sine for theta, I'm going to switch it up and use cosine for phi. So if I use cosine, I would see that cosine of phi is equal to the adjacent side, which here would also be the side with length 4 divided by the hypotenuse. And then I have to take the inverse cosine of both sides so that I can get phi by itself. So phi is equal to the inverse cosine of 4/5. And again, make sure your calculator is in degree mode, and then we find that the angle phi is equal to 36.9, yep, that's right, 36.9 degrees. Okay, so if I've done my math right, remember that the interior angles of a triangle should add up to be 180 degrees. My right angle here is 90 degrees, so if I do 90 plus 53.1 plus 36.1, I should get 180 degrees if I've done everything correctly. And let's just double check to be sure. So we've got 90 plus 36.9 plus 53.1, and that gives me 180 degrees. Good, our triangles work. Let's do one more example here. So I'm asking you to find x. We know only one side of the triangle, and we know only one angle of the triangle. Actually, we know two angles of the triangle because we know that this is a 90-degree angle. One side is a length of 5. That side is opposite from my angle, which I'm saying is 30 degrees, and we want to find x, the hypotenuse here. So what I'm going to do, since this side is opposite of my angle, and I'm looking for the hypotenuse, I'm going to use sine theta. So sine theta is equal to opposite over hypotenuse. So it's equal to 5 over x. X is what I'm solving for. So I've got sine of 30 degrees equals 5 over x. Okay, so I want to solve this equation for x. I want to get x by itself. So what I can do is multiply both sides by x. Okay, that cancels the x on this right-hand side and leaves it on the left-hand side. So x sine 30 degrees is equal to 5. Now I have to divide both sides by sine 30. So the sine 30 cancels here on the left-hand side, so x is equal to 5 over sine 30 degrees. Okay, and again, since we're using degrees here for my angle, make sure your calculator is in degree mode. So 5 divided by 30 degrees, sine 30 degrees is equal to 10. So my hypotenuse is equal to 10 units.